Suppose we have a list of constraints for our function f. What are the trade-offs when solving for a single high-degree polynomial versus taking the point and derivative constraints and using them to fit k-cubic Hermite splines? So as we talked about in lecture, we don't want to solve for a single high-degree polynomial because it makes these hard to control. So if we have a very large number of control points for one high-degree polynomial, changing any of these control points will cause some change in the entire curve that we may not be able to control that well. Whereas if we solve for k-cubic Hermite splines, then we can change one of these control points and only affect that section or that one cubic Hermite spline. So while we'll get a continuous line and we'll still have a continuous derivative, we will have a higher amount of control on this line, because if we change just say one of the middle points, it'll only affect the Hermite spline to the left and the Hermite spline to the right, because none of the other splines, although they're connected, none of the other splines use that information to determine its shape. So overall, it's better to fit k-cubic Hermite splines.